Well, hi, and welcome to my shop. Today I'm going to be doing something a little bit different. I'm going to be looking at this very classic recording meter, an Esterline Angus recording meter. A ubiquitous meter, was everywhere back in its day, and I happen to have one. I have one here. So I liberated this from the company I worked for just before they threw it in the garbage. That's right. And you know what? I've had this for a long time now. Maybe 20 years even, and I've never really done a thing with it. I just grabbed it because I thought, wow, that should not go in the garbage. And so it's just hung around with me all this time. I can tell you this, yeah, it's portable. It's got a handle. I cannot lift it with one arm. That's how heavy this thing weighs. An absolute ton. So a lot of these meters you would see, these recording meters, are mounted in panels. So this one has a heavy-duty box it's mounted in for field use. Exactly how this was used back at Toronto Hydro, I don't really know for sure. I don't really know all that much about it, frankly. So let's check it out. Now, I am familiar with this kind of meter, so this isn't a totally cold thing for me. Let's pop it open. Okay, and I'll take the cover right off. Here's the scale. Looks like it's bumping into the pointer a bit. We'll leave the scale flipped up. So there's just some interesting things. Beautiful looking gears. Spare set of gears for changing the paper speed. Just stored in there. There's the stop, hour feed. It says minute feed there, so maybe there's two speed settings. Chart drive. Esterline Angus company. So this is on this part of the machine here that does the paper drive, basically. Let's flip this. Look at that, eh? Just like that. I just flip it and the clock mechanism's going. So conceivably the paper's moving now, but very slowly. Fast and slow. There's no electricity in this. I don't see anything. I see these are moving. Oh yeah, the paper is moving ever so slowly. There's no electricity in this whatsoever. It's all mechanics. The way you wind this up. One way or the other. Okay, push it in maybe. Now I'm winding something. Okay, so I think I just wound it up a little bit. Let's go a hole here for it. Snap it back in. So the paper snaps in and out of this. You can see these little inviting levers here. If we push these down, then we can take the bottom out. There's the paper source down here. How much is down there? Ooh, I think there's a lot. I think it's got a lot of paper left in it. Which when the paper runs out, I may not be able to get any more. Although, hey, we live in the world of the internet, so there probably is possible. Here's some charting here. Goodness knows what that's from. Up. Recording charts. There's probably various companies making the paper. Goes there. We just pop it back in. There we are. Now on this particular machine, if you're sharp-eyed, you've already noticed something odd down here. A variable resistor has been installed. The input terminals are here. So there's a positive here and a negative there. You can kind of see the negative post and the positive. Oh, look at this. Somebody wrote here. Coil resistance 62.5 ohms. And then what's up here? What's up here? This says 24 volts DC. And that up there says RHPEN. RH pen. Right hand pen. Maybe it's to make the pen go the other way. I don't know. Right hand pen. 24 volts. Because the scale on this meter is in milliamps. It'd take 5 milliamps to make this meter go all the way over to here. I mean, this is not a highly sensitive meter by any means. It's not meant for highly sensitive use. It's mostly meant for use in control boards where the voltages that are being provided to something like this are have been managed or engineered to be what they are. It's not the kind of thing you just go out and let's go check and see what the volt is on that, voltage is on that. It's not the way these things are used. Well, let's see if we can get it out now. There's hold down screws up here. These are captive screws. So they won't. I don't think this will fall out. This is the kind of thing that this company manufactured in the hopes of making these by the tens of thousands, hundreds of thousands perhaps. And so this is a highly engineered, highly designed machine. One of the things they'd be most concerned about is making a machine that causes trouble. They get 100,000 of these things out in the field and then they all have a problem of some sort. That wouldn't be very good for your business. So that's why this thing looks so heavy, so highly engineered, especially compared to today's instruments, right? Today's instruments, they don't look like this. Of course, they look more like this, right? Did I get them all out? I think I did. So now this unit should come out. What's going to come out? Oh, you know what we have to do? I think we have to do this. Maybe not. We can leave some stuff. I'm going to take some stuff out. I'm going to leave it in there and see if we can pull the unit out. It's still hanging on up here. Hanging on somewhere. Oh, I see. So this bizarre little guy has to come out. I haven't figured out what this is. I did take a little look at this last night to see if it was worth doing a video about it, and I thought, yeah. Okay, so out comes the chart recorder part of this meter. That's just these things falling down. Gonna fall over. No. Okay, there. Well, there we go. So we're going to put this part away for now. And this is heavy. Look at the way this thing is built. Oh my gosh. Thick, really thick aluminum. So this must be where the spring is that I wound up right in here. This must be just for advancing the paper as you need be. Some more of the drive mechanism, I guess. So you can see the modular nature of this meter. It has two modules. We've got the mechanical module right here out front, and what's back here is the actual electrical meter we'll look at in a minute. But clearly, if you got a little bit of trouble, you could change this part of the unit and leave the rest in place. Yeah, two modules. Not really very impressive, is it? How do you put the paper in here? So I'm not going to worry about that because the paper's in there. Great. What a beast, eh? These are the bumpers for the meter when it's going back and forth. What a beauty. Okay, so we can set this, which incidentally sits perfectly fine on its own too. Put this back in here. Maybe it'll help us understand what it is. Everything's black in here. Let me put a little more light on it. Let's read what it says down here. Maximum circuit voltage 750 volts, full scale millivolts at meter, and then there's a place to write it. It's not written. A place where somebody would stamp it in. It's not stamped. Maximum circuit voltage, full scale millivolts. Millivolts at the meter itself. Okay, this is all blank here. At end of leads. Say that. Millivolts at the meter and at the end of the leads. I guess you would do this in the laboratory before selling this. The manufacturer would fill this out. Esterline Angus graphic ammeter for use on DC. The Esterline Angus Company Incorporated, Indianapolis, Indiana, USA. Serial number 99,196. So, you know, did they make 100,000 of these things? Oh, I'm sure they made many more than that. Zero adjustment. So if you just watch the back up, it's a big meter. Watch this thing move. If I move the zero, kind of clunky, isn't it? It's kind of sticky. We'll look at this more closely in a moment. So that's how you zero it up. Now, let's take a look at the actual movement in here. Light on it. So this is a huge magnet. What do you think? Yeah. Yeah. One gigantic magnet here. Interesting. This is all clear, so you can look right in at the movement. I'm going to switch to the close-up camera here because this is interesting stuff. Almost like technology found from another planet or something, compared to the way things are today. So that's inviting to undo that knurled part there. I'm not going to, though. There's some. Is that the more knurled parts inviting me to turn them? So look at it now. So here's the wires. There's two wires here. Coming into there, two black wires going up. Oh, those have to be the supply wires. Look, there's nothing in here. There's nothing electrical about this. You see, one of them's coming from there. You know, that does not look like, that connection does not look like something the Esterline Angus Company did. That looks like something else. Maybe that's why there's joints on these wires here. I'm not sure. But I'm fairly sure what I'm going to show you next is not original. This is somebody at Toronto Hydro did this. So they've stuck a variable resistor here. It's only two wires coming to it, so it's just a variable resistance. And what is its value? $100R. So I think it's 100 ohm, I think. That's what that would be, 100 ohms. And all they've done is just put it in series with the leads coming in. So somebody was doing something with this meter that this was an advantage to them, I guess. Some kind of calibration thing. What's this screw doing here? Boy, surely to goodness that doesn't belong in here. Okay, so we've looked at this part here with the mysterious plates in there. Those could be some kind of sliding contact. It looks like springs. Those look like springs. Yeah, those are springs. Let me move the thing up here. Oh yeah. Yeah, when I'm moving the pointer back and forth so you can get an idea what's going on. So those are springs. This other silver one here isn't even another spring. Why have got so many springs on this? Is those really springs down there? Sure look like it. So you might think of these springs as, and I'm just guessing here, analogous to the alignment of a radio, in the sense that you're aligning these different coils in a radio to get a certain result. Maybe these springs combined produce some kind of tension result that allows the meter to be mostly linear in its operation. That's a good guess. I got no clue though, really. Yeah, that's the adjustment that I was moving. Should have to move all these springs. Yeah, just turning the whole piece there. I'm just moving this. Turning the whole piece. So see, the knurled thing here is in a slot, as if you can make adjustments up and down or something. I don't know quite what that is. So we'll head up now to the big, powerful, what I assume are powerful magnets. Oh, a little more information. So this is on the actual meter movement now. Measuring element. They call it the measuring element. And another window to look through. Can't see much other than the shaft. Let me turn the zero. Can't really see anything moving there. Let me move the pointer. There, that's all moving now. What is that? That's moving a big... That's a coil. That's a coil down there. That's a coil rotating around a magnet. I'm pretty sure that's a circular magnet with a like a donut, and the shaft is going down the middle of it, and then this stuff's rotating around. And you can see the wire. The wire turns right in there. What's usually tiny in this meter is a great big thing. Okay, we come up a little higher, and now we're looking at the reservoir cup and the pointer. A little more light on it there. Okay, so a bit of a close-up camera shot here. So this is the actual meter movement and pointer writing on top. I'll lift the pointer. Okay, so that's the pointer out. See, the pointer has an axle it rides on. And it has this front part. It's actually a pipe going through that slot. We'll get a better look at this when I pull all this out of the meter. I put the pipe in the slot. I put the axle in the thing. And there you are. Looks like a counterbalance on the back here that can be adjusted. Now, what I'll do to move the meter, I'll move the zero, and you'll see the meter movement move here. Just hold still. Kind of gives you an idea what it's doing. And then that big gray thing there is actually a pot of ink. A pot of ink. Okay, so we're going to take these parts out, and then there's this thing. Now, this, what is this? So it's hooked up back there to a thing. You know what this is? You know what I think this is? This might be a timer marker. So this little coil here obviously is operating this arm, which is going to swing back and forth. Let me pull the cup over here. This thing here, like a Morse code kind of thing. So I think what this does, and maybe it's broken. Maybe the tip here is missing. I think it's another inker. This is the ink pot, and it's drawing down the side of the page, and it would be like a square wave sort of looking line, and you could indicate. You know what you could do? You could probably activate that from a distance. Maybe it's some other timing mark. It's a timing mark of some sort. I'm pretty sure that's what that is. This just must be a weight, or maybe this rides on the paper here. It engages back there. And then what would this would have its own terminal somewhere in the back. I don't remember seeing those. Okay. So when it comes time to put ink in this, you take out the pointer, you take out the ink tray. There it is. Ink goes in here. I have some. So when I brought this in my shop yesterday, I opened it up. This fell out. So it looks like there's ink in there, but it's only a tiny amount. I mean, you want to put a lot in here. And then the pointer tip, the pointer pipe going in the slot, and then it's riding. And how come the ink can travel all the way down this pipe and come out the end? And the reason is the very tip here is very tiny. As it drags on the paper, and the ink is drawn out of the tip, it causes ink to be drawn in from the can. That's as simple as that. So the trick with these is to get these things started, to get ink all the way through here. Maybe that's what this is for. Maybe that's the whole idea here. Maybe you do something. Yeah, you do something like that. Fill this pipe full of ink. Something of that sort. Don't know if I really want to try this in terms of making a line. We'll see. Still got more to go. So, again, pretty rugged, right? You got to think about clumsy people. Like this fairly sensitive instrument is being sold to pretty clumsy people, like me. So it's got to be built in such a way that it can take, real world use. Look at how easy that is. Of course, it has to be made to be easy. Easy to set up. There we go. Now, it seems to be going low. Maybe if the paper was in here, this would then sit up on top of the paper a little bit. And my pointer's bent over a little bit, but I'm going to leave it bent over because if I straighten it up, it may come right up. Let's give this guy some power here. I think I'll just do it in the open like this. We don't need the chart recorder part in there. It's so black, it's just hard to get everything on camera. Okay, so this is coming from a power supply. Control the voltage on the end of these. Right now the voltage is 0. I'm just clipping this on the terminals back here. The lower terminals. So this thing would be operating as an ammeter, supposedly. I'm going to have to pop this up. It might get caught in here, so it's going across. We don't have the scale there. Okay. Okay, let's watch the pointer here. Whoa, there it goes. So in terms of volts, that's really like 1 volt. It's really not even on the meter up here. There we are, all the way over. Still working perfect. Nice. And it kind of supposedly it's 5 milliamps full scale. 5 milliamps really isn't discernible on this meter. No, I can't see it at all. So I don't know what the current is. We'll assume. I mean, it's an instrument. It probably is exactly 5 milliamps to get out here. So these upper terminals appear to be connected to here. So when I read this as 24 volts here, that's because it takes 24 volts to operate this little mechanism up here. That's not another input for the meter. I misinterpreted that. So that means you could send a completely independent signal from somewhere, 24 volt signal from somewhere to this meter and make this piece pop, 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 or actually I guess it's going back and forth a little bit, writing on the edge of the page. What I'm sure are timing marks or critical points in time that somebody wants to mark on the chart. Otherwise you got to stand there with a piece of, with a pencil, right? And try to mark it. That's kind of awkward. Well, good show. What's left to do here with this? As a voltmeter, investigate what's going on with this thing. So this is cranked minimum resistance here right now. Minimum resistance. So I'm going to move the meter up again. Okay, we'll put it right there. Oh, I've been jumping around. I guess the terminal is falling out there. Now I'll take this and just move this. It's going the wrong way. I'm increasing the resistance here. Yeah, it's going the right way. Increase it all the way. Maybe that provides a bit of protection for this meter too, from people like me. Well, it takes more now to make it go. Maybe double. Okay, let's put the chart back in. What could I do with this? The one thing I have thought of that I could potentially do with this meter, I guess this has to be up, is I have a small solar cell outside about this big, and it powers a light in my garage that comes on and off automatically just over our door to the house, and it's great all summer, but in the winter there isn't enough sunshine to charge up the light. Maybe this shouldn't even be in here during this process. There's not enough sunshine to charge the light, so I switch it to a little power supply and charge it that way all winter. That leaves that solar panel out there doing nothing. Could that solar panel just operate this meter? So, oh, there's another thing that has to come out before you do this. This guy. There we go. This is very heavy. Where do you grab it from? Maybe here and here. Is you going in further? Maybe not. Yeah, this isn't exactly your pocket voltmeter. Here, let's put it like that. So the year that this was made, I don't know. It didn't say on it anywhere. I would guess it's the 1950s, early 60s through the 60s. They probably start manufacturing something like this, and then it gets ubiquitous. It's everywhere, and then people need to replace them and maintain them and on, and they decide they don't want to have 6 different kinds of instruments for their instrument guys to understand. They'd rather have one, so they keep coming back to this, to this, to this. So this probably sold for decades. That's my guess. Which is why you see them almost everywhere. And when I say that, I don't mean see them everywhere. We see them everywhere in old movies. I keep forgetting to say that last part. I watch the American TV channel, the NASA channel. I watch that a lot, actually. You know what the thing about the NASA channel? That's the American Space Administration. Watching that channel is you get to see wonderful human beings doing wonderful things all the time. No bullshit. Just wonderful things being done by wonderful human beings. Thumbs up to the American space program, for sure. And Canada and many other countries have a role to play in that, partnered up with the Americans, so more thumbs up on that. So I literally do that. If I'm watching TV and it's getting to me because of what I've chosen to watch, I check out the Space Channel, and sometimes there's old documentaries there. They're kind of fun to watch. There's a lot of rah-rah for America. I can tolerate it from back then because, you know what? You're on your way to the moon. There was a lot to rah-rah about back then. And yeah, gave me a very hopeful sort of youth watching what the United States was doing with the space program. So, NASA channel. Watch human beings being what human beings are really should be doing. Now this is way off the paper. This isn't set in, that's why. This must not be set in right. So that's better. Now it's working right. Just bouncing on the paper. Of course, you don't want any drag here, right? There's any amount of drag here, and the meter's going to stick. Then you'll have the China syndrome, right, where the guy goes. Hey, that's real. That tapping on meters, that's a real thing. And some of you are going to know that because you've done it. But for those of you who think that was a weird thing, no. Tap on your meter. Tap on your meter. So I'm just having fun here today. This is the objective here, because tomorrow I'll be starting on a great big radio. It's going to go on for a couple of weeks, and I got to recharge my batteries after the last little radio I did. Just about finished me off. Okay, let's make it go across now. There we go. Have I got it up? Sort of brainlessly. No. It was not brainless. I thought I had these on backwards. No. I'm just checking about turning the level up here. There she goes. Yeah, so I hooked this up to my little solar panel. It's going to produce enough milliamps, I think, to operate this, and probably too much, probably. And then the position of the chart would indicate the amount of sunshine hitting that panel, or how sunny it is. So I could either choose to look at this meter and interpret its results, or look out the window. I could do that too. So I think that's it. I don't think I can do too much more with this. Pretty happy. Found out it's actually all here. All here and all functioning. Just have to think of something good to do with it now. Great, thanks a lot for watching this. I think the next thing in here will be a big radio. Maybe I have another thing to goof around with first. But the big radio is on its way. Thanks a lot for watching.